All right, doors are closed, so let's get started. Ah, wonderful. Good afternoon, everyone. My name is Ingo Simonis. I'm with the OGC, and together with ESIP, we organized a coverage processing and analytics sprint over the last 2 days. We just assembled the slide set 20 minutes ago, so this is really just-in-time processing. And this is our report on what did we do over the last 2 days. We will have several presenters, so bear with us if we need to change presenters from time to time. But we discussed so many things over the last 2 days, and we would like to give you a very broad overview of what we did, what's the current status of discussion, and that's why we bring in the experts for the various elements and aspects that we discussed. The OGC APIs, who is not familiar with the development from the more service-oriented architecture towards those service/resource/REST, even though some people get red faces when they hear REST type of architectures. Are you all familiar with what we do in OGC? That comes out of a couple of recommendations developed together with W3C as part of the Spatial Data on the Web working group. That was one of the first consolidated efforts towards the new design of those interfaces that we use in daily operations to access data, to process data, to visualize data, to do anything with data. And we have applied a new process to the development of those APIs, different compared to how we did the service-oriented architecture services that started roughly in the late 1990s and continued for the next 20 years then. The new approach is extremely open. There's a public GitHub repository, there's a public GitHub channels, public phone conferences. And we have modified the development process of the standards. We go very long with version 0.1, 2, 3, until we have reached a very high maturity, and we do lots of testing in between. We bring in lots of implementations before we actually move from specification to standards. And with those APIs, we really focus on the developer experience, and that is for sure very nice for the developers because their interests are reflected by the design. But on the other side, for sure, we need to bring our user community into these discussions as well. And that's one reason why we have those, let's say, mixed audience sprints. We do bring in the developers, we bring in the users, the user community, and together we try to identify the key building blocks that we can reuse across all those different services for the different data types that we do have. Why we are here? Well, we definitely want to get together, as I just said, and it's extremely important to test as many scenarios, to explore as many scenarios, not only on paper, but even by coding some clients and server prototypes. Bring this all together and then provide the feedback to the specification or standardization process to make sure that all those experiences become part of the new standard when it gets released. This is not an isolated effort, right? You can't read this, but the thing you see in the center, the one we have the red square around it, that's today. That's the OGC ESIP sprint on the coverages. And the red squares are different events. So we had a sprint or a hackathon on features. We had one on catalogs. We have several, and these are the yellow rectangles here. We have several major innovation program initiatives where we support the development of those various APIs. And as you can see, at the bottom, you see the time axis, and it goes into 2020, 2021. We will have future activities already lined up. And over the last couple of days, we just discussed additional meetings that we most likely will need. For example, a sprint on processing or a sprint where we bring in all the APIs. Here, the last 2 days really focused on the coverages, even though started already the discussion how the coverage API is actually related to all the other APIs. In theory, it's very simple. In theory, you have a landing page, you go there, and you just follow all the links until you have reached what you want to see. Or you have read the standard, you know how the APIs are structured, and you can directly jump to your favorite coverage. And you may have some additional filters or subsetting elements just afterwards. It just gets very, very complex very quickly once you want to do something a bit more sophisticated than just access some data, right? As soon as you want to bring in several data sets from different collections, you want to do complex filtering or subsetting, you need to overlay different data sets, then run some analytics and have a nice visualization at the end. Well, then you need to bring in all those different components we have, all those different APIs that we are currently discussing. And what we will do now is we will see where we currently stand with our discussions. So I'm looking for Chuck. I don't see Chuck in the room. Who's our first speaker? That's interesting. Well, Jerome, maybe you can come up already because you're the second one. He made the slides, yeah. Well, let's, yeah, we can jump to the EO section and then come back to this overview thing. That's okay with you, Jerome? Okay. Who does the EO? Chris, Patrick, Tom? Okay, you know best from where your slides start, so I'll let this. You find your slide. Well, perfect, right? Okay, here we go.
Thanks. Thanks. So as part of the sprint, the PyGeo API project is a Python-based server implementation of many of the OGC API standards. So our participation in this sprint consisted of coming up with an approach to serving coverages through the software. So we started from ground zero yesterday, and we built out an approach for building coverages, which included a Rasterio and NetCDF plugin, as well as an Xarray plugin. So here's some screenshots. This is the default Swagger instance that you would get from visiting the server, and here we can see some sample endpoints using CMIP5 data as our coverage. Here's an example of getting some of the coverage offering information, so you can see the envelope of the various axes. Here's an example of the Xarray provider that Gregory and Gallagher did. Sorry, I forgot your first name. It includes processing a ZAR file on disk or connecting to an OpenDAP proxy. Now I'll move it over to Dave. Is Dave in the room?
So this morning when that client became available, I just started to play with the hypermedia that it writes out from the landing page and then kind of descended down. So started at the base URL, got some JSON hypermedia, found the data I wanted, got the collections, and ta-da, we can plot up some data, which was a pretty useful exercise. It was relatively trivial from a coding point of view, but we pretty quickly identified a number of items in that hypermedia that were, easily overlooked in the implementation, but totally critical to the spec and to the client implementation. So we've got a Python implementation as well.
yeah, so, and that was, I mean, pretty cool that we were able to that rapidly just spin up. Well, awesome that they could get the PyGeo API working so quickly. And then in the morning that we had to play with it, put together something. And we had, I think, 2 or 3 iterations of deployments and modifications, and like it was a really rapid, really, really nice. So then one other thing I just wanted to mention, the first day of the sprint was largely discussion and kind of architectural thought experiments. And one of the big things that kept coming back was this distinction between features and coverages, and how the data distinction between features and coverages interplays with the API distinction between features and coverages. And so I have up here 2 kind of use cases, if you will, in that. So Stack, the spatiotemporal asset catalog, uses the feature API for assets that are ostensibly coverages. So it's representing typically granules of remote sensing as using the feature API to discover them, but those things themselves are actually little coverages or large coverages depending on the asset. So that was an interesting thing, and we talked through that quite a bit, got a little wrapped around the axle a few times. Then the other one is, you know, I work a lot in this environmental linked features world where features are observation locations like stream gauges or buoys, right? But they're either samples of a coverage, or the feature itself, say the feature is a watershed, like the watershed itself could be represented by a coverage. So we have this interplay where we go back and forth between things that are identifiable and fields essentially that vary through space. So I just have this list. So and I talked through this with George and Ethan and various other people. So I felt like putting a slide up about it was useful here. So it's very important to note that with the features API, a feature collection, excuse me. So a feature collection can form a coverage just in general, right? You can have a bunch of watersheds that cover the landscape. Each has an average runoff, right? So you have a coverage of runoff for the whole landscape that's represented by a collection of features. But a feature collection is a feature. So in the features API, the OGC API for features, you can have nested collections of collections because a feature collection in its own right is a feature, right? So you can kind of have this aggregation as you go in and out. And so given that, a coverage can actually be seen as a feature because from 1, 3 follows, right? And then a feature can actually be represented by a coverage. So these distinctions, while it's easy to kind of get wrapped around the logic and wrap around the axle, it's pretty important to note that it's not one or the other, it's really both. And there's an interplay between the two as you zoom in and out, or you have different representations of the same data layer. So anyways, with this new OGC API, I think we're really going to start seeing the API being a view of data. And you may have a feature view of that data, you may have a coverage view of that data. And what the underlying data is kind of arbitrary as far as the API is concerned. So it's kind of a functional view over top of the data. So anyways, I just wanted to share that insight that I think was significant coming out of the sprint. And I don't, is Peter here? We kind of peppered slides in through here. We can, yeah, there you
go. But not that part. Let's see. Where's the slideshow on this? Got it, thanks. All right, so carrying forward in the demo category, Dave showed this demo. Aaron Fries did a demo client And this is where we learned it's very fortunate to have a server that's up and running early in the sprint so that your clients can actually develop against that. It's maybe something I'd underappreciated before we got to this, before we started the sprint. And so the point here is just to show how simple, the code can be to essentially construct the query for what you need to get out of the coverage server. And here's a little example. And keep in mind that this is done over a total maybe 6 hours of working, I think, all in all. So it didn't really take a lot of time to go from a standing start to having a result that you can actually plot up. Also, Amy Barchauskas did a small server. This is done in conjunction with the multi-mission analysis and algorithm project, where we've been worrying a lot about how to do remote subsetting because it's a joint ESA-NASA project. And so this is, again, just an idea of showing you how simple this can be when we strip down to this API approach versus some of the older, more complicated approaches. And here's what some of those sample requests look like. Then I think, and then Peter, did you want to talk to this?
So, joining the caravan, we have provided, let's call it a spike implementation, using the rasterman array database system. And if it works as it should, then we could, for example, do that subsetting request here, where we use the subset parameters along the axis and get back a JPEG image from this thing here. And here it comes. So that shows that subsetting part, which is not the B box, but the other approach that is coming classically from coverages. But actually, the main thing is about WCPS sending requests. So in this setup here, where you see that service endpoint, we have a parameter Q that contains a string. I've colored that for being easier to read. What does it do? We go into this Sentinel-2 false color image. We do a subsetting, that's the green part as before, and we do the NDVI on that cutout. And we would like to see that as a JPEG. So that is something that would do the same thing right now. Wait, where do we stand here? I see that I've copied the wrong link, but doesn't matter. The next one does a little bit of a different thing, an average, and so we would get back a single scalar value. But maybe the more interesting thing is to see that live in the Swagger editor. So if that works here, I can, is there a way how to copy that in a single go? Does Control-C work on a Mac? For Command-C. Command-C, okay. So I should have the whole thing here. And if we now go over to the Swagger editor, edit. No, I don't want to convert, I want to delete all that. Command A, cool. And then there is something like delete, and the command should be Command V. No. Yes, cool. Okay, and we get the whole thing that we see in here. But there are all these definitions, and well, let's just do it, get the thing, try it out, and if we scroll down now, we see the execute on that query here, which we can see again, well, we've seen it before. So by now you understand the pattern. You can set up such a service that actually receives as input parameter a string and receives delivers as output parameter a set of coverages or a set of scalars if you do aggregation. And that's where we stand currently. Actually, this is already obsoleted as always, in particular with sprints. What we discussed earlier is that we would have something like a WCPS equals parameter. Why that? because we can have more than one such query languages, say CQL, for example, and this way you can easily dispatch into the right parser. So that's the WCPS parameter. Why would we attach that to collections? Because WCPS allows you to do data fusion, to access different coverages and combine them. And therefore, it doesn't make sense to attach the query to a single coverage, but it must operate on collection level in general, which is the same like probably with other languages like CQL as well. Therefore, collections is maybe a good place to attach this query parameter. Okay, and that's my part. That's this slide.
And that showed very nicely also the advantage of the open API for having that Swagger editor that allows you to do some very quick turnaround testing. Now, one discussion that we got into with respect to EOS-DIS data. EOS-DIS, NASA's EOS-DIS has a lot of different data products. And to make things more confusing, we sometimes call them data sets, we sometimes call them data collections, and both of those terms kind of conflict with other standards terms. And so this presents a challenge for the flat structure of those WCS coverages, those API coverage requests, where a typical request looks like this, this one down here, this base coverage API, where you've got this root URL, in this case just acme.com, then you've got collections, and then you've got a placeholder for that coverage ID. And so you can see that there's really only one set of coverages you can provide at this level. That provides us with a problem because we've got up to 1,000 variables within our data types, and then the 6,000 data types. So we're probably looking at hundreds to thousands of potential coverages, which is difficult to manage or present to a user in a flat list. So we talked about some hierarchical solutions. These are three different solutions that tweak the URL a little bit. The first one is a kind of a resource style where we've added an implementation specific part on the front where we'll put in our own EOS-DIS CMR collection ID in order to scope it down to just one data. I'm going to call it a data set / data collection / data type. That same approach can be taken with the query style, where instead we're moving that to the end in the query. Again, it's implementation specific, and so both of these do not really interact with the spec. They can be safely added on by the implementer without affecting its conformance with the specification. We also looked at a couple that actually would require spec changes, one which actually has a recursive sense to it, so that you can have collections of collections in the URL. And you can see here that we've repeated collections here where I put in our EOS-DIS collection ID, and then collections down here where what I have is something that's a little closer to the data variable level. And then lastly, we also looked a little bit at doing that hierarchy through the responses instead of through the URLs. And this is actually a little closer to, I think, to what David was talking about with respect to, collections can be features and those can have features and, so on and so on. We haven't really decided which of these four solutions is the best going forward. All right, like I said, the first two require no change to the spec. They might go into best practice or something. The second two would require a change to the specification. Is Chuck here now? There we go. All right, ready for that.
Okay, where are we at? Ah, yes, okay. So one of our main objectives of this sprint was to determine whether or not the API specifications we have so far are sufficient to meet our overall goals. That is, are they sufficient to define an API which implements the modular building block approach that we have envisioned for our API standards? And the answer is we're not We are still not sure. We have a challenging use case to find out. What we also did during this sprint was we took the goalpost and they moved it way down there. So while we had a pretty good idea coming in, now we have a pretty good idea. Don't have a pretty good idea, but at least we have a way forward, which is actually a good thing, because the last thing I want to do is come out with a standard which is not everything it should be. So I consider that a win. What we have is a kind of a vision of a large organization's web presence, if you would. It has an API sitting on the landing page, and it has all these data and processing resources back behind it. And this diagram here is basically the path diagram. So you've got collections, you've got catalogs, you've got processes. Behind those, you've got maps processes, contours processing, and so on. But the key thing is that every box on this diagram has an API. And I've got to get all these APIs to play well together and to send data back and forth to each other in order to make this thing actually work and solve users' problems. In this case, my problem is that sitting at the landing page, can this thing give me a soil map? That's my question. I've got no idea what's back here. I just have this pretty landing page with nice graphics on it. So can this answer my question? A couple things which are interesting about this is we look at the soil data. Soil data is available as both features and coverages, which means this box now has to have both the coverage API path as well as the feature API path sitting on the same landing page. It is a combination of two different standards in one implementation. If that wasn't bad enough, our postulate is that our Landsat data is established in a pyramid. The top pyramid is low resolution, medium resolution, high resolution, which means that what I need is a concept of a coverage, which is a collection of coverages, which is a collection of coverages. Right now, coverages doesn't do that. We've talked about it, but it doesn't do that. What we do have, however, is stack, which is a form of catalog, which is a form of API feature. Features, feature collections do support collections of collections of collections. So what we essentially have here is we have a feature API on stack, which is our metadata catalog for accessing the layers in our coverage APIs. So now we have a case where a feature API and the resources behind the feature API are describing a coverage API and how to access the content of that coverage API, which means now we have two very different APIs which are closely coupled together in how they operate. Kind of a challenging situation. So we put all this together, we put it into a PowerPoint is nice, yes, but when it comes to actually having some rigor behind what you're doing, I fall back to UML. So we took all of those boxes, we stuck them in a UML tool. We started building the sequence diagram showing the request response pairs between them. I'm going to hit you with 4 sequence diagrams here, I believe. First one is general discovery, which is I'm sitting at the API, I'm sitting at the first landing page. Tell me what is out there. And among the things that happen, I learned about this map process. This map process can generate me a soil map, which is what I want. Great. Next question is, what kind of inputs do I need for that process? That information comes back, and now I know what I have to go look for. And also, it tells me where to go look for it. The next one is data discovery. This is where I'm going to go out. Now, one of the things I need for a soil map is contours. In order to build contours, I need a digital elevation model. It happens to have SRTM, Subtle Radar Terrain Mission, which is a global digital elevation model. Great. I'm going to go get some of that. It has soil data. And once again, as you recall, the soil data is in both coverages and features. So I have to decide if I want coverages or features and then go get that information. So I've done this. I've got my my DEM, I've got my soil information, and now I'm going to go get my imagery. So first of all, we assume that both all the Landsat data stores have published to our feature catalog. I mean, that's kind of a given. So now it becomes a simple matter of taking this big, massive, and it's all actually multiple pyramids, because our L5 Landsat data is not the same store as the L8 Landsat data. So this catalog has to keep track of 2 or more completely different data sets at different levels. And I'm going to go to Stack, and Stack's going to do that for me automatically. So all that complexity is now hidden among multiple federated APIs. And then finally, given all that information, I'm going to kick off the map process. Here's the data, here are the parameters, go give me a map. The map process goes off, hits those same APIs again, because I don't want to move the whole content around. What I'm pulling around are the references to the content. The processors who's actually going to go out, hit those APIs a second time, and actually pull down the content, muck with it, put it together into a map, and give it back to me. So as you see, as we walk through here, there are a lot of interactions between a lot of boxes and a lot of things that normally are not really designed to work together. We want to make sure that the standards we develop will actually work together and support this kind of a use case. Another reason why I'm using UML is you'll notice that first box on the upper left, I can actually specify the path, the actual URL used in the request, and I can specify what the returned resource is, which helps me drive down another level of detail to understand exactly what each one of these transactions looks like, what's being passed in and what's being passed out. So the UML model allows me to do that, document it with some degree of rigor, which is more than I can do with a drawing tool, which is why we're doing this. But that's still a work in progress. So anyway, basic idea, we have a complex use case. We think we understand what needs to be done to implement it. We're going to continue to model it, validate it in the model, continue to try to validate it in software, and all the things we learn will get rolled back into the standards. That's it. Questions?
Right, thank you very much. As you can see, we are exploring more and more complex use cases. If you have use cases, we're always interested in it because they allow us to do exactly what Chuck has just presented, to walk through all those elements we have. And sometimes a bit difficult understanding when we talk about APIs and the different APIs and features API and coverage API. Well, in fact, it's all elements that you can bring together in one single implementation if you want, or you can have it on a number of servers and a number of instances. It's logical building blocks, and these building blocks need to work together smoothly. That's what we have just seen. If they do, you as a user can access the first server, and that will almost guide you to all those other elements, right? And all the complexity is somewhere hidden behind. We just hope that this will work out soon. So, all right, thank you very much. We would now like to give you a very brief overview, Stefan, Chuck, on what we do next in terms of. Oh, yes. I'm sorry. Confused. Jerome, please come.
So to lead into Jerome, is you saw that use case? It's actually originally Jerome's use case. Jerome has gone one step further and has taken the human out of the loop. So now it's not just human gathering stuff. We now have analytics, software, which is doing all this stuff for you. And I would say that software is pretty dumb, so you have to be very careful how you stuff.
So my goal with all of this is that any OGC API implementation, whether it's providing data or providing services, like computing power, basically they can all work together like one big OGC API that's worldwide, that's all interconnected. So any data set anywhere is available to any data scientist and Anybody can contribute additional processes, contribute additional data, can catalog data, present it all into one easily searchable single geospatial. You could imagine a single OGC API, which all the OGC API publish nicely with nice metadata, nicely categorized and all this. So that's kind of the idea behind all this. And it really comes down to two very, very simple fundamental types of OGC API resources, processes and collections. I don't like the term collection much, but it's the data layer. So that's either your coverages or your features, or maybe it's a data collection that can be presented as both. Maybe all of them can be both presented as features and coverages. What's special about a process is something that takes inputs and it outputs something from inputs. Typically, you could maybe have a process that generates data from nothing, but there's limited use case for that. Most of them will consume some data and produce one or more output. So what we did is we prototype a simple JSON schema that can actually make all of this possible based on these two fundamental data types. And basically it's a flexible workflow that lets you daisy chain any level of complexity. And the use cases we considered is rendering maps, which I consider as a process, because you give it a bunch of data layers and you basically want to produce an image out of that. So to me, that's kind of like a very good example of a processing service, right? And another example is generating vector contours from a digital elevation model. Another example is using a stack API, and which is going to, you can give it a search criteria, and it's going to identify imagery scenes. And the result of that will be a vector feature collection, which can then be an input into another process, which can basically access these buckets and present it to you using a coverage API. So that's another example of a bit more complicated process, which actually works. So there's both a feature collection API there, which is the stack instance, and then you have a process that takes that feature collection and basically generates you a coverage out of this by accessing the S3 buckets where the data actually resides. And the other use case it's many use cases, but it's different kind of processes, which are actually generic processes, which allows you to upload the algorithm to where the data is. And to me, this is where WCPS would fit very well, because you can define a process basically that you give it a WCPS as a parameter, and you can use the input system to give it multiple input collections, which can themselves be the output of other processes. Another example is executing the ADIS containers in the EO use cases, like they're in the test beds, and also executing code. So you could upload code to the data, you could upload container to the data, and all of these are processes which can work with this generic system of inputs and parameters. It's basically that simple. It's just input and parameters and processes and collection endpoints. So next is the actual, what the JSON could look like. So here we basically, at the top level, this document is being posted to a maps process, which is going to return you a maps. And there's the two main sections there. The first one returns you your imagery layer, and the second one returns you your the output of the second part is a vector feature collection. So that's your contour lines as vectors. The top part is your imagery as your imagery layer. So it's basically your base map, and then on top of that, the map processing will render the contours. So there's two layers input to the top level map rendering service, it's imagery, and then the vector contours. And so then if we dig into the first one, it actually uses two processes, and then it nests the stack at the deepest part. So if we look at the deepest part, we're basically looking for Sentinel-2 scenes with less than 50% cloud cover between May and September, and with a sun elevation of below a certain threshold, and we want to sort them by descending order and only have a unique row and path. So we cover everything and we get the most recent imagery without clouds and in the summer and well lit. So that's the search criteria, and the stack will give me back this is not proper stack, by the way. I didn't have a chance to figure out the proper syntax, and I'm not very familiar with stack myself. But basically, as you point to that collection there, which is your stack collection endpoint, and the parameters that you give it will result in a vector feature collection. Now, that vector feature collection becomes the input to a process, which I call stack to coverage, which presumably is somewhere else.com. That's where it's hosted, whereas the actual stack was on Amazon.com. So that other process will work on that feature collection and will basically access the S3 buckets and generate out of this a coverage. So these two together will speak feature API. Then that one will also directly access the TIFF files or whatever it is that's stored in the S3 buckets, and will provide a coverage API. So it will speak with the level higher up, it will speak coverage API. And the one higher up, what it does is it takes the Sentinel-2 bands and converts it to ARGB image. So it does the panchromatic sharpening, the atmospheric correction, it selects the bands, and it produces you an image. And that image is your input for your map, which combines the base imagery with the contours on top. And it's just a very simple example of which is actually a complex workflow, but it's presented in a very concise manner, which is actually quite flexible. And if you go to the Gitter, I have a more involved descriptions with a lot of comments and a lot of more complex use cases. And the idea is all of this can be, so once you've defined this, you'll notice there's no area of interest described here. But this whole process, you can add to this your VBox and your resolution that you want this, and you get your map like this, or you can give it tiles and you can access this by tiles. And basically the data scientist on the client side can tweak his settings, and it just has to, the whole workflow only has to be executed on maybe 8 or 10 tiles. So and all of these tiles can be executed across all of this entirely in a distributed manner. So you can get almost instantaneous synchronous feedback. So you can tweak your settings, and once you're happy with this, you can actually pose this to a /collections endpoint to create a new bake collection, which then anyone can access using their regular maps or as styles. And anywhere along that workflow, two endpoints can decide what to speak. They can speak coverage, they can speak features, they can speak DGGS, they can speak tiles. They basically negotiate between them based on the conformance classes, how that part of the workflow should be executed. So that's kind of the big idea here. Any questions? Thank you.
All right, so correct me if I'm wrong, but now we should look into the future of our specifications. So Stefan next, then Chuck. Do we have Dave in the? Yes. Okay. Good. I hope so. No. That is a common. That is Chuck's coverages. Next steps.
Cool. Thank you. So as already was mentioned, we are developing the specification in an open GitHub repository. So this is really the invitation to everybody to come look at the issues that we have, put in your perspective on the different things that we have. We even accept pull requests if you want to. So take a picture of the URL. In addition to the specification, or part of the specification is the open API definition that we have. So this is on Swagger Hub. You can grab it directly from there, have a look at it, and also please send your comments, especially if you have an implementation, if you're an implementer. Well, I would be or we as a group would be really interested to get your feedback if this is actually implementable, what we have thought out here, in addition to what we have tested over the last 2 days, of course. So what we do in the group, in the OGC group right now, is really we want to finish up this specification based on the results that we have developed the last 2 days. We want to resolve the last open issues that we still have. And ultimately, we hope to have soon a vote in the group for a release as public RFC, which is the next step for this specification to become a standard. So we will hear afterwards from Chuck, but we follow right after all the common part of this API. So this again also an invitation if you want to. We are holding weekly teleconferences, 10 a.m. Eastern or 4 p.m. in Europe, where we discuss these things and advance the specifications. So if you're interested, please let me know. I can give you the details to join those teleconferences. And as I said, really any contribution, any feedback is very much welcome, so that this next round of coverage standards really gets big adoption in the end.
Stefan, any questions for Stefan? The GitHub repo will be populated more and more, even with implementation that we do have, both server and client, so that allow you to experiment with the current status more and more.
One part to add, if you have an example that you want to add, that would be very important. From the example from the sprint, this PyGeo API that was presented previously, we have already added as an example. Examples are very welcome.
Good, that was coverages. Now we look into other elements, and that is common. You know where to find it.
I know where it is. It's actually twice up. And so when I look at this, I have my second slide. Why don't you? Okay. I see what I think's there, not what actually is. Okay. Google's helping me. Got it. I'll escape out and come back. I might do it. As we mentioned in our kickoff for this sprint, one of the objectives is to try to break the specs we already have. And in that we have certainly succeeded. Woo, okay, we're done here. We can go home. There are a number of things which there seem to be consensus that we do need to do, either fix or add to common. And I'm going to go through them. This will take just another couple hours or so. First of all, API Features has developed a CRS, Coordinate Reference System extension, and there seems to be consensus that that should be an element of common, because looking at it, we don't see anything in there which isn't also applicable to coverages. Mind you, this is something we have to do a serious validation of, because the feature world tends to be geocentric, whereas the coverage world tends to be more esoteric in their coordinate reference systems. So we want to make sure that it is not doesn't make simplifying assumptions in their CRS extension. But as long as they don't, the proposal is to take CRS as a extension to common, which means that any API could take advantage of it. Similar situation with the filtering extensions. API Features has come up with their CQL extension. That's a common query language for running queries against a feature collection. It seems to be very similar to the subsetting extension which API Coverages has. So the question is, if they are in fact functionally equivalent, shouldn't they be merged together and moved into common? So this is a bit of homework that needs to be done, but a few folks have asserted to me that it is. Assertions is not proof, so we have to do some due diligence here. Limits. API Features has a concept of a limit. The purpose of a limit is to restrict the amount of data which comes back. So you do not accidentally go and issue a query which downloads 16 petabytes of data to your laptop. This was in an earlier version of Common. It was taken out, but now there seems to be a lot of agreement that needs to go back in. So we will roll it back in. It does raise a question that whereas if I set a limit on a feature collection, I limit the number of features that come back. If I set a limit on a coverage, I'm really more interested in limiting the volume of data, the number of bits to come back, rather than the number of coverages to come back. A 5 gigabyte coverage is still a 5 gigabyte coverage, and it's still too much for most people. So we may need to redefine that, or at least we may need to write the common version of limit in such a way that coverages can specify it for coverage resources to have a slightly different behavior than it would for a feature resource. A little bit more homework to do. Last one on this page. It was intended that when you do a bounding box or use the bounding box or the date time parameter, that it would work on both the collections as well as the collection ID path. Apparently that is not clear, so we need to go back and fix that in common, because the intention was that you can filter at any level. Questions on this page? Yes. Mm-hmm. Was that on limit? Oh, you mean limits on the? Well, now we have a bounding box. Daytime limits the temporal extent, but limit is more a limitation on volume. So it's an attempt. It's really there to keep you from downloading inadvertently more data than you really want. And another characteristic is that it assumes that it allows an API to impose a default limit. So if the user does not override the default, there's a limit to how much I will give you at one time. It kind of it goes together with the next and prev, yeah. Now I think.
But if
Well,
you're going to pull limit into common, you kind of have to pull the rest of that system.
Yeah, the rest of that system gets pulled into common. The question is, how much do we standardize in common, and how much latitude do we leave you to modify that for? I mean, what we get down to is limits on feature transfers are not the same thing as limits on coverage transfers. It's somewhat different. Oh, okay, it could be the maximum number of coverage elements that come down. Yeah, we'll kind of kick it around. I think date time deals with your other issue, which is already in there. Which, yeah, so I'm not going to defend the examples because a lot of them are out of date. So it's part of the cleanup we need to do. Yes.
Thank you. Could you also add in there like keywords and resolution or scale in here?
Now that is, I have 5 issues up there on the GitHub labeled with hackathon to be addressed during the sprint, and no one has brought that up until now.
Yeah, I was busy with other things.
Well, this is the report out.
So there is an issue out. I think there is a general understanding and agreement that the content of the resources that come back right now from Common are sparse. I mean, they are very minimalistic. We probably should put more information on there, but I need someone's agreement as to what needs to be in there and how much is mandatory, or do we simply leave it open?
But the idea is to be able to discover the collection, right? By spatial resolution. I don't care about way low resolution. I can eliminate 80%
Remember,
of the
this
data
is,
set
this is
by
common, this is common, this is not coverage.
anything, it's a
Okay.
collection, not coverage. Any data set I can eliminate by saying I just care about resolution, high detail, or I just cared about keywords. I want temperature data.
As a filtering,
I think Chuck's point stands. He has an issue open for you to submit that to.
I will. I'll add.
all right, make an issue.
I do have another question.
Yeah.
Daytime
Can you wait for the microphone? Sorry.
Date time on features, there's a single date time, right?
As I recall, yes.
So, but with collections, it's a temporal, it's a beginning and end time. So how, like that, the definition for how that's queried is different for collections versus features. Like, what is that? Because I can give a start and an end time. So what does that mean if my collection has a start and end time as well? Does that mean that both dates should fall within the interval? Does it mean that any of them, it's just a simple intersect? Like, the logic there just has to be defined is all.
So-
Like, you
so,
can't
yeah,
use the same logic for both of them. Okay. All right. So
Yeah.
we'll just want to make sure that that's
But-
specified in
but-
commons
but
though.
I think we take the issue that it needs to be, the semantics needs to be better defined. And even if that means pointing to the W3C best practice. Okay.
Okay. Okay, cool.
Peter? Slow down, Peter.
Actually has led, work in the coverages group at some time has led to a temporal domain working group. I wanted to add that one, where some folks, in particular Chris Little, have added a lot of cases. So day-night is one thing of periodical, where you don't have just an interval, periodical access transcending that algebraic approach, but you also have seasons. You have the transition between day, month, week, and years. You have the climate people who have 360-day years and stuff like that. So that can get pretty ugly.
It is common. It's supposed to be simple that you build on in other APIs. Yeah.
Whether it's a temporal coordinate system that has a continuous coordinates or whether it has a calendar in it, like what we should be
Mhm.
addressing. The calendar date is into that temporal, the temporal reference system can have a calendar, a temporal coordinate system has, it's a lot.
Yeah.
It's a whole lot easier. The algorithm is actually a lot more important.
So the agreement was in the temporal domain working group to have seconds as the base units. Of course, you can go to higher resolution with sub-seconds, but then calendars, where we currently typically talk about one, the Gregorian proleptic, but we don't talk about the Japanese imperial calendar, for example. Then there is a time of validity for the calendars. Just think about this year 0. So did we now go into new decade or not? So we will have all sorts of transitions and discontinuities when we go into the past in particular. Oh yes, in the future as well. Some politicians really want to abolish leap seconds, and that would mean to a change in our calendar system as well.
Peter, I think we need to tend this somewhere else. Can you make an issue?
I can. Should I?
You want to write an issue on the GitHub? We'll go from there.
Okay, we'll do that.
Now we have slide 2. So what you saw in the use cases involved a lot of passing around information about where a resource is. And when you get right down to it, we're talking about passing a parameter by value, which is when you provide the whole chunk, versus passing by reference, which is when you pass a reference that allows the process to get it directly. We need both, particularly when you're doing an orchestrated or very heavy analytic workflow. because you do not want to be moving the data any more than you have to. In fact, in many cases, we prefer to move the processing to the data rather than the data to the processing. Having identifiers helps us do that. If for no other reason, it greatly reduces the size of the URL and simplifies the URL that uniquely identifies the resource you're pointing to. Now, it happens that in the OWS Common, which is the web services analog to API Common, they have something called Get Resource by ID, which is something that all OGC web services are supposed to implement. I say supposed to. It's really not out there in most of them. But it is a very simple operation. It is get resource by ID. Here's my identifier. I don't care what the resource is. I don't have to know what the resource is. Just give it to me and I'll figure it out later. If I'm sending a resource to a process, get resource by ID is a very compact way of sending a resource I've already identified to the process without having to include an entire query string and everything else that goes with it. There it is. There are some issues with this. One is we have to figure out what exactly is being identified. I could be identifying the digital representation of something that is a single digital instance, or I could be identifying the real world entity which that digital instance represents. In many cases, you need both because they're used in different ways for different purposes, but it's a discussion we need to have. Should the identifiers carry semantics? The textual-based identifiers very often are based on, well, I want to do this, I want to know the date and time it was collected, and I want to know this, and I want to know that. I get all this metadata encoded in an identifier. That's not scalable. And I will sit here and rant that identifiers should not have semantics. There should be no meaning in an identifier, but I'm sure people disagree with me. Qualified names are interesting. The challenge is you need an identifier which is globally unique across space and time, because resources can be archived and they could still be accessed 50, 60, 100 years from now. It'd be nice to have an identifier which is still valid at that point. One way to do that is to use a random number generator, which is great up to a point. Further restricting them by using a qualified name helps. I guess I'll speed it up. And finally, this question, should it be resolvable? Unless you put it as part of a URL, identifier is not in itself resolvable, but there has been efforts to build a identifier resolution service, basically built on a DNS type model, which will allow you to submit an identifier and have the URL, plural URLs, come back to where that identifier, that resource can be accessed from. Finally, we have the notorious .f-f parameter. In API features, we're very adamant. Content negotiation is done per W3C using HTTP content negotiation, which means headers. Counter argument is that you don't always have access to the headers. So the -f parameter is being proposed to go back in the common to allow you to do content negotiation through a URL parameter as opposed to through the header. And I'm done. Questions, comments, flames? Okay, thank you.
Thank you, Chuck. Dave, your opportunity to advertise your session tomorrow before we come to a conclusion.
Tomorrow afternoon,
if you are into this kind of thing, webby data, structured data, that kind of thing, tomorrow afternoon, there are 2 sessions, one from 2 to 3:30 that will be kind of lightning talks from a whole slew of people. We're going to be more linked data, semantic web oriented schema, scienceonschema.org is going to play a role there. Some environmental linked features information stuff. A whole bunch of international projects are going to be presenting. Should be a good lightning talk session. And then following that session will be kind of open time for people in that session and people from the coverage of Sprint to get together and talk about kind of how do we start to converge some of these ideas? What are some actions we as a community can take to bring this all together? And then following that, I'm hoping to have a number of webinars on these topics at the IT&I webinar series. So hopefully we can build a little momentum coming off of this in the kind of linked data, scienceonschema.org and coverages worlds, and then continue that momentum offline. So be there.
All right, thank you very much. That brings us to the end of this session. Are there any other questions, not necessarily specific to last advertisement, but in general? As you can see, and I think all participants of the sprint can confirm that, standardization can be fun. So I think we had good fun over the last 2 days. We entered the room at 9 in the morning, and in the afternoon we had first implementations up and running. So sometimes it's just fun. Saying that, well, it's time for me to say thanks everyone for joining this session. Thanks in particular all the sprint participants. Great time we had, and you did a very great contributions. We have good summaries already, and I would like to hand over to George and Annie. Do you want to say some last and final words?
So yeah, I wanted to thank some folks. You did that just now with thanking all the folks that were part of the sprint that really did a whole lot of good work. Let me also thank ESIP and Annie. So OGC and ESIP have been partners for a long time. Our CEO spoke in the opening plenary, but we weren't there because we were in the sprint, right? So we were working hard, but it reflected that coordination that's gone on for a long time. I think this particular item of the sprint is a real manifestation of that partnership. And again, thanks personally to Annie for all of the things that she did to get this. And so this is part of a process. We may end up doing some things in the summertime at ESIP too. So do you want, there's rules in these ESIP meetings, Annie.
If you're within ESIP, you get questions of kind of, are you OGC? Or you have to all the time say, no, that's an OGC thing, and this is an ESIP thing. So it's nice to have an event that has brought our communities together, and particularly for this event, people that might only normally participate in OGC events were exposed a bit to the ESIP community, which was, I think, a personal and organizational goal. And so we hope the people that were brought in by the sprint have had a chance to kind of scope the broader ESIP community, and it gives a bit of a carrot dangle to get people to come back in and continue to participate both in our meetings and other online collaborations. So we were really excited, and I hope we can, do this again in the future. That's it from me. Anything else? All right. Thanks, everyone.